I want to talk to you for just a minute about the best way to study for these chemistry tests. I think that some of you are doing fine. You know, if you're doing fine, then just keep doing what you're doing. If you're floundering a little in this class, don't give up. It's too soon to give up. We're only just in January. I want you to consider this. When you are completing the homework for the week, the homework is pretty minimal. It's just read and do the on your own questions. However, if what you do is read and it's kind of swimming around in your brain, and then you look at the on your own questions, I know it's very easy to just flip back there and look and see, the right answer, and then say, oh, okay, well, that's how they did it. But that's not really the same as being fluent in the problem solving. It's being able to do it on your own, actually on your own, and check your answer and say, yep, got that one right. Yep, got that one right. To be really well prepared for a test. And that's why I always put the answers to the extra practice and the review questions, is because everybody needs more practice. I think it's understandable the first time through to check the on your own and just sort of see how they do it. That's the part where you're learning. But you can't just stop there and then walk into the test. It's not enough practice. You need to practice the problems to the point of getting them right by yourself. Okay? So I'm just going to encourage you to take a little bit of ownership of your own mastery of the information that's being presented. If you walk into class and it's a test day, which is every other week, and you haven't done that step of proving to yourself that you can do the problems by yourself, then you're not ready for the test. And it doesn't really help for me to stand up in front of you on those test days and try to, review/cram. If you're not fluent in the problem solving, that's not going to help you. It's too late. It's a sinking ship. Okay? So you have all these tools, you have all these problems to work. You can call me. You can call your friends. You can ask for help. Please ask for help. Don't just flounder at this point. Okay, now, let's see. I really, really want to get to orbitals. Oh wait, can't do it yet. Nope. The next thing we need to talk about is the more advanced model. After we're done talking about light and wavelength and frequency, we go back to atomic structure again and models of atomic structure. The very first thing we learned about the plum pudding model, not correct. Then we learned about this sort of like planetary, like electrons orbiting protons. Better, but still not quite there. Now I want to talk about the Bohr model, the Bohr model of the atom. So this starts on page 224. Niels Bohr is credited with this. Pretty amazing. So at this point in time, now we have theorized and I guess also somehow proven that neutrons exist. So now there are 3 subatomic particles that we've got to place into the framework of a model: protons, electrons, and neutrons. So this is the idea that Bohr had, and I think it shows true scientific genius to be able to even come up with a model. This is what he said. He said protons and neutrons exist in the nucleus of the atom, and electrons exist in orbitals. Orbitals are kind of like circular paths that go around the outside of the nucleus. He also said electrons can move from one orbital to the next, but it requires energy for them to make that jump. And we call these electrons that have moved to a higher energy state excited. So this concept of levels and jumping, this is key. This is where we get the word quantum. It's the levels. So now we're still not totally there. Bohr's model is really amazing, but it's still not 100% correct. And who knows, maybe what we've got now is not 100% correct. Now we have something called the quantum mechanical model. And really the only difference between Bohr's model and what you would learn about today is the shape of the orbitals. They're not circles. They're not perfect little circles where the electron orbits. They're more like clouds. And they don't have the same shape. Every orbital has a different shape. Okay, so now this is going past what you learned for this past week. but it's kind of hard, and I don't want to leave it all for next week. So I'm trying to decide. I think I'll tell you a little bit about this, and then I don't know, maybe I'll do another video lecture. So we have these things called orbitals. If you want to look in your book, you can look on, the Bohr model is on page 226, which shows little electrons traveling in neat little circles around a nucleus that contains protons and neutrons. The quantum assumption was good, but we have some more to add to this now. Okay, so there are different kinds of orbitals. The orbitals are the places an electron can theoretically be. First of all comes the s orbitals. The s orbitals, I would say S stands for sphere. That's easy. I'm going to change colors. I'm tired of blue. How about purple? Okay, so the first kind of orbital is the s orbital. And I would say S stands for sphere because it's a spherical shape. Here's our nucleus with protons and neutrons, and each s orbital can have 2 electrons in it. And they're all going to be sphere shaped, they're just going to get bigger and bigger, farther away from the nucleus. We call this the 1s orbital, we call this the 2s orbital. Next comes p orbitals. P orbitals, I would say P stands for pump it up. P is for pump it up. It's a dumbbell. It looks like a barbell. Like this kind of shape. Or a dog bone. Okay, so the p orbitals are, they're illustrated much better than that in your book on page 230. They actually kind of look like this. Here's your nucleus. And how many electrons can be in each p orbital? Well, there's 2 in this one, in this plane. Hold on, I know. There's another p orbital. If this is the x-axis, then this is the y-axis with 2 more electrons. And then there's a z-axis that I can't really draw very well, but it would come out from the plane of the whiteboard and extend behind. And so there's 2 more. So if you add them all up, that's 1, 2, 3, 4, 5, 6 total electrons in each p orbital. So there's 2 electrons in each s orbital and 6 electrons in each p orbital. Now before your brain melts, there's one more orbital that I want to talk about. This one is called the d orbital. D orbitals, I'm not even going to try to draw. I've looked it up. There's a whole lot going on with multiple axes of symmetry. Basically, I would say the D stands for, I don't know, D. But know that they exist. And for each d orbital, you can have even more electrons. Let's see if there's a good chart that lists all this information. Yeah, it says the shapes of the d orbitals are very complex, so I will not attempt to illustrate them for you. But you do need to know that there are 5 different d orbitals, so 5 times 2 is 10. So we've got 2, I'll write on the board. For s orbitals, 2 electrons per each. For p orbitals, 6 electrons per each. And for d orbitals, 10 in each. It's like there are 5 different shaped clouds, and in each of those 5, 2 electrons exist. Okay, now, the next thing, and this is the thing that most students stumble over, and they think it's harder than it really is how to write an electron configuration. It's really not that hard. I'm going to show you the way the book does it, and then I'm also going to show you the cheater method, and I'll send a handout, or I'll send something that you can print out and look at home. The block method, you use the periodic chart, and you regard that chart. You know how it has kind of a funky shape? Let's see, where's Celeste's chart? Have you ever wondered Why in the world it has this shape? Well, this might help you to feel better about this strange shape. If you move helium all the way over here, right next to hydrogen, then this would be your s orbital block. And then over here, again, helium's gone. This is your p orbital block. And then this chunk in the middle, we're going to ignore purple. They're really large and have orbitals that we're not even going to learn about. Those are the f orbitals, or forget about it. So these are s, p, and d orbitals, this middle block here. So you can actually use the chart to help you understand how many electrons and how to write this electron configuration. Okay, let's do it. The electron configuration is going to consist of a bunch of numbers and letters and subscripts. And at first it looks very confusing, but hang on, it's really not that bad.